There. Oh, I gotta turn that off. Okay, great. Can you hear me?
I can hear you.
All right, I can hear me. So, in like a couple of hours, you're gonna hop on a plane.
Yeah. So slight panic in the background here while I'm like doing the I left my airplane pillow where panic mode.
Take
But
all those thoughts and just put them away. All you
yeah,
need to think about is the sun.
no, all I have to think about is SOHO, which is not the same thing as the sun.
So where are you going?
Bandung, I think that's how you pronounce it, Indonesia. I'm going to the Southeast Asian Young Astronomers Conference.
That's really cool. So what are you going to be doing?
I'm giving a talk on how you can maintain collaboration at a distance and be an effective scientist no matter where in the world you might be located. And I'm doing a workshop on all the technological tools that are available completely for free online for academics.
You may be an expert at this.
I just might. It's kind of surprising how rural America in some cases is just as underserviced as as the bigger cities in the developing world.
Yeah, yeah, but I mean, when you think about all the technology that we have at our
Yeah.
disposal, all the stuff that we've brought to bear on this problem with the Hangouts, and
Right.
it's
And we've figured out how to do just about everything for free. And we live off of the generosity of the people who donate to this program and to CosmoQuest. And with all the funding cuts going on, please donate to CosmoQuest. It's all I want for Christmas. Um, it's it requires us to find new and creative ways to do amazing things as the money dries up.
super interesting. So we're going to no, it is interesting. I just know we got to move on,
Yeah,
which
yeah,
is
yeah.
yeah, that's really interesting, Pam. No, no, it's great. Are you going to be streaming any of this online or any of this sort
Yeah,
of
we're
thing?
going to stream the entire conference. I will probably be starting to set up the Hangouts once I make it to LAX and finish a bunch of other things that are on my to-do list. I had a choice last night, complete everything on my to-do list and not sleep, or decide LAX was going to be pwned of internet.
They got pretty good internet there.
Yeah, they do.
Okay, so if you don't know what we're doing, we're going to do a live episode of Astronomy Cast, episode 322. Today's topic is SOHO. Normally we stick around for half an hour or so and answer your
Not today.
questions about space and astronomy. Not today. So Pamela's got to rush out the door the moment we finish. And
Yeah.
yeah, and so this will be Monday's episode. Now you're going to be back in time for the Monday after that.
Yeah, I will be extraordinarily jet lagged, like never before jet lagged, but yeah, I'll be back.
Interesting. All right, well, we should pick a really philosophical topic then. Okay, cool. All right, well, let's get rocking.
Okay.
Um, I got a new monitor, so the positions are a little funny. Okay. I'm ready to press record whenever you are.
Okay, I am going to
I
banish the
disappeared. Man,
dog
I'm
that
like a
just came
mountain
in.
man today, aren't
Hold on, I have a dog. You, leave.
I?
Small, white, fuzzy, long-clawed dog on hardwood. Not good for recording. Okay, I've pressed record. Wow, that's big sound. Okay, I need to not
Testing, testing.
project.
I'm good.
Okay, I'm now good.
Okay, great. Here we go then. Hello, script. Okay. Astronomy Cast, episode 322, SOHO. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing today, Fraser?
Good, although it's early in the morning for me on the West
Yeah,
Coast.
yeah, sorry. Thank you. For those who don't know, I'm about to abandon the United States yet again and fly off to Indonesia via all airports in between here and there and give a talk at the Southeast Asian Young Astronomers Conference.
How long is the trip going to take you?
Yeah, it hurts. It's 4 hours from here to LA, then it's 16 hours to Hong Kong, and then it's 6 hours to Jakarta, and then it's a 6-hour bus ride to Bandung.
Wow.
Yeah.
But you're going to be streaming this live, although I guess when people hear this, it will have already happened. But anyway.
They'll watch the YouTube channel.
Yeah, you can watch the YouTube channel. You can see what happened. And you're going to be, what's the sort of purpose of the conference?
It's to basically bring together the youngest, brightest astronomers from all throughout Southeast Asia and help give them a leg up on how to be successful in their careers as, well, they bring astronomy to these developing nations. And very developed in some cases.
Right. But I mean, the great thing is, as you can see with what we're doing, I mean, we use all these free tools to reach wide audiences around the world. I live in Canada, you live in the States. The people on our teams are all around the world, and it doesn't matter.
Right. And what's going to be kind of awesome about this is I get to walk in and give the message, it no longer matters where you are. There are things like money that are useful at really big universities, but there's so much you can do for free right now, and this is something that we have to figure out every day at Southern Illinois University Edwardsville because we just don't have the resources. And as I said in the pre-op for this show, all I want for Christmas is donations to CosmoQuest.
All right, well, donations to CosmoQuest. Go to CosmoQuest or astrosphere.org.
CosmoQuest.org/donate.
There you go, and donate. Okay, great. So as we've mentioned before, the sun is a terrifying ball of plasma. It's a good thing we're keeping an eye on it, and that eye is the Solar and Heliospheric Observatory, or SOHO. Operating for more than 18 years now, SOHO has been making detailed observations of the sun's activity through an almost entire solar cycle. With so many years of operation, SOHO has some amazing stories to tell. So this is one of my favorite missions, I got to admit. Because it gave us a view of the sun that I'd never seen before. The pictures coming out of SOHO were just transformational. So let's talk about the mission. So where did SOHO come from?
It started out of a European mission that had been conceived. A small mission initially that was planned to just look at the sun constantly. Some astronomers who'd gone down to Antarctica in the late 70s and done 24-hour observations during the summer months down there realized how much more there is to learn through constant observation of the sun. And so planning began for a mission that they hoped would launch in the early 80s that would simply sit out in the L1 Lagrange point between the Earth and the sun, that gravitational balancing point that allows you to orbit the sun at the same rate that the Earth is orbiting, and just send back image after image after image, allowing us to understand all the different activities that our sun is capable of, and also provide an early warning system for some of the nastier things it's capable of.
And I think, we're so used to it now. I mean, we have SOHO, we have SDO, we have Hinode. There's all of these spacecraft.
Stereo A and B.
Stereo A and B. So there's all these spacecraft now watching the sun because this is important.
Yes.
But this was the first really permanent eye in space watching the sun, right?
And what's kind of neat is even though it was developed to be a little tiny European mission initially and ended up not being funded, instead they went after an infrared mission, the idea was considered so important that rather than scrapping it or waiting for funding for another tiny mission, they partnered with NASA and ended up creating a much larger spacecraft capable of doing a lot more science. And so when this mission finally launched in 1995, it had nearly a dozen instruments capable of everything from measuring the solar wind to looking at the surface of the sun to blocking out the sun and measuring the solar corona and unexpectedly discovering comet after comet after comet after comet.
Right. So what were the main objectives then of the spacecraft? What was its real mission?
Well, its fundamental mission was to provide 24-hour monitoring day after day after day of the solar surface and the surrounding corona, to watch for solar flares, to watch for coronal mass ejections, and start to piece together what are the details of the solar cycle? How is it that our sun changes over the course of those 11 years as it goes from minimum to maximum and then reverses its path? it's done that like a champ. And we realized that the sun was so interesting that coming up after this was the Solar Dynamic Orbiter that took what SOHO started and increased resolution by a bazillion, it feels like, increased the cadence of how quickly the images are taken. And this was that first low-res camera compared to SDO that let us in on how it is that solar flares develop, let us in on how it is that coronal mass ejections break and release energy into the corona and upper levels of the sun.
I mean, there's some of the instruments are I mean, if you go to the SOHO website, you can actually see the views of the sun that are in sometimes like almost real-time images, and it's
Right.
based on the instruments. So you'll see the LASCO image, right? The low to outer corona, and then that's one.
That's the one that's used for comets.
Yeah. And so it's interesting how, I've become quite familiar with the instruments because that's how they describe the images that you're seeing. Like, oh, this is a LASCO image. I think they've done a really good job of sort of helping us understand what instruments are on board. But what are some of the instruments on board this spacecraft?
So you have the coronal diagnostic spectrograph, which is out there trying to get at what are the different spectral lines that we can see in those outer parts of the sun, what basically is that hot gas. And with spectrograph, you can start to understand the temperatures, the fluctuations in temperature. There's CELIUS, which is the charge element and isotope analysis system. And that first instrument, it came from Rutherford Appleton in UK. This next one came from the University of Bern in Switzerland. This is an amazingly multinational spacecraft.
Yeah.
There's COSTEP, which is the Comprehensive Suprathermal, I love that word, and Energetic Particle Analyzer. It's from the University of Kiel, which is also in Germany. You have the Extreme Ultraviolet Imaging Telescope, which is one of the ones that makes those amazing all-disk images that we all love to just eat up. It's from the Institut d'Astrophysique Spatiale in France. There's the energetic and relativistic nuclei and electron experiments. So here we're looking at what's the lag between the visible images that we see, the flares, we see the coronal mass ejections, and when the high energy particles actually start to get to L1. That one comes from the University of Turku, which is in Finland. There's the Global Oscillations at Low Frequencies instrument, which is also coming from France. And there we're starting to look at, well, our sun is actually a variable star, but the surface is essentially jiggling like jello in a very mathematically precise kind of way. There's LASCO, the Large Angle and Spectrometric Coronagraph, which is where we're finding comets. That one's actually a United States instrument coming from the Naval Research Lab. There's the Michelin Doppler Imager from Stanford. This is where we're starting to get at the speed of how things are moving on the surface. There's the Solar Ultraviolet Measurements and Emitted Radiation, the SUMMER instrument, which is from Max Planck. SWAN, the Solar Wind Anisotropies from France. Ultraviolet Coronagraph Spectrometer from Harvard. The Variability of Solar Irradiance and Gravity Oscillations, Virgo, which is from Switzerland. It just goes on and on. This is a mission where basically every heliophysicist in the world goes, oh my God, if only we could. And they built the instruments that, for their time, were basically the best you could get for observing how the sun's surface fluctuates, how the corona heats up, cools off, changes, what things look like in visible ultraviolet, just all those imaging high energy colors, and then starting to get a sense of what are the particles coming at us.
And I know the mission was only supposed to last for 2 years, but as I mentioned, we're closing in on 18 years now.
Right. So this was a mission that when they launched it, the goal was keep costs down. It got bigger when they added NASA and ESA. But it was kind of an experiment. How will this work? They developed all these new technologies. And it's producing such great data that they just keep expanding it out, expanding it out, expanding it out. It's currently funded to go through 2014 unless something really bad happens in both the European and U.S. economies.
Right. I mean, I know that there's some funding issues for a lot of the missions right now. I mean, I've heard that some missions may get defunded and have to get shut down. So,
Yeah.
yeah. And so I keep offering. I can speak for all of Canada that if any of this gets shut down, we'll pick up the tab and keep these missions going. I promise. So,
If only it were that easy.
but
Sadly,
the
it's
prices are very low. The amount to keep, Cassini and stuff going, very inexpensive. We can totally afford it. Um, But right, so but I mean, so 18 years of operation. What's great is that's almost a full solar cycle.
right. And as we head towards 2014, we're going to get to see another turning point from maximum towards minimum and start to see how does the sun look as it changes from one phase in its cycle to the next. Um, and this is a mission that really, by putting everything live in almost real time, it's constantly being listened to. There are hundreds of kilobytes per second coming back from the spacecraft, which when my internet runs that slow, I get annoyed. But when it's a spacecraft, that's kind of awesome. And the mission's been consistently putting all of its data online as quickly as it can. And this has allowed everyday people to participate in the science the mission's capable of and showcase what can be done in real time by NASA and people working together.
Yeah, and there's been tons of discoveries, and of course, the one that you've mentioned a couple of times is this discovery of comets.
Right. So we always knew that there was a class of comets that basically they're the suicide comets, the sun grazers, and they're on extremely elliptical orbits where they pass sometimes so close to the sun that it's not passing past the sun, but rather diving straight in. And we knew they existed, but we didn't know how many of them existed. A lot of these things, they're so small, we just don't notice them. They're on orbits that cause us to never really get to see them because they're constantly in daylight. A whole myriad of different reasons. But with this particular instrument, they have a chronograph, a disk that blocks out the main part of the sun and allows us to see the beautiful gas of the upper levels of the sun's atmosphere. And it also captures all of these comets. And in fact, people discover comets at a rate of 1 or 2 every 3 days. And that's kind of amazing when you think about it. Since it launched, they've discovered over 2,400 different comets. One particular individual is responsible for over 100 of these discoveries, and that's Mike Oakes. And they actually named an asteroid, which I find amusing. They named an asteroid after this comet discoverer. And there's actually a really good TED Talk by Erin McKean where all of these amazing discoveries and how if you give people access to data, they'll do science. All of this is highlighted in her TED Talk.
Yeah, I mean, it's just like, where else can you do this, right? You can look through this data from this spacecraft and be the first person to spot
Yeah.
comets crashing into the sun and help, contribute to our understanding of this phenomena. It's awesome. And now SOHO's been going for 18 years, but it hasn't been without its problems.
No.
Now, what kind of problem did it suffer?
Well, I think the most traumatic and one of those mistakes that leads me to believe I'm not allowed to touch the software for a spacecraft because I am not that careful. It actually was sent some bad commands, and this sent it into a fascinating shutdown mode where we thought we might have lost it forever. Couldn't contact it, couldn't contact it, couldn't contact it. Ended up using powerful radar to confirm it was still where we thought it should be. But it essentially lost its ability to be pointed at the sun for a little while. And it entered a very slow tumble, and they were able to realize, okay, it's about to realign itself with the sun. Let's try again to get contact with it. And they were able to reestablish communications, fix the software, and get it going again. And that's one of those really amazing rescues that can happen. And it's kind of frustrating to think that it happened due to bad software, but then it got fixed.
That is terrifying. Like, as a software developer, when we're both software developers,
Yeah.
and this, how many times have you pushed a new update of your code and everything breaks, and you
Yeah.
have to go and like you physically get access to the machine and fix it? But with spacecraft, you can't physically
No.
go there and access them. So every time you push an update, there is a chance that you have bricked your spacecraft.
I never thought of it that way, but you're totally right. It's bricking it, yeah.
You are bricking it, yeah, and there is no way you can't like get in there and like swap out the hard drive and or reinstall the operating system. It's done.
Yeah.
It's gone. You bricked it.
There's no shutting off your instance and returning to the prior image of it. Yeah.
Yeah, but you know what? That is not the problem that I mean, I knew about that one.
Oh, you were thinking of the gyroscope.
The gyroscopes. Well, we have to call. I'm going to call this the I don't know, the Fraser Initiative, the Cain Initiative, which is to always send more gyroscopes.
Well,
so what did it do? Ran out of gyroscope.
yeah, it's the standard problem. This is over time the gyroscopes essentially wear out and stop doing their job balancing the spacecraft. But this is a spin-stabilized spacecraft, and they were able to figure out how to use its wheels to keep it going, essentially turning reaction wheels into gyroscopes in a certain way.
Yeah, yeah. Well, I know initially they relied on the thrusters and realized that was going to run them out of fuel really quickly, and then they came up with a method of using their reaction wheels, and problem solved.
And what's kind of neat is this method, figuring this out allowed them to keep Fuse, which is a different spacecraft I think that we've talked about. They managed to keep it going longer. Over time, we are finding ways to escape the great gyroscope debacle that so many spacecraft happen to deal with. It wasn't useful for Kepler, which is still kind of limping out of commission. But with this spacecraft, they brought it back.
So what does the future hold then for SOHO? Where we stand now and what's coming up?
Well, it's going until at least 2014. I think many of us are eagerly waiting to see what happens as Comet Ison passes around the sun, and we're able to observe that in SOHO. I apparently like to abuse solar missions for comets. Then of course, as we exit this solar cycle, its suite of instruments plays a role along with SDO and all of the others in trying to put together the detailed picture of how do we predict when coronal mass ejections are going to happen? How do we predict when sunspots are going to form? How do we predict when they're going to lead to solar flares? And we're working to build a model for understanding the sun's weather, hopefully better than we understand our own weather here in the middle of the United States. Weather prediction, no matter what the system is extremely complicated. But with the sun, the better we get, the safer our astronauts, the safer our spacecraft, and the safer our power grid.
Yeah, I mean that cycle. It's we mentioned it's a 22-year cycle. 11 years to go from minimum to maximum, then 11 years to go from maximum back to minimum. And so we've gone from minimum all the way to maximum, or some combination of this.
Right.
But we haven't seen the full cycle to get right back to the starting point from when SOHO made its observations. And then, I mean, even better, more amazing would be to come back around and see the cycle a second time with the same instruments, and then you could really put together all of that data.
And that's where funding starts to become such an issue. It's only alive until 2014, And that doesn't get us 22 years. We're going to need another 4 or 5 years of funding, depending on whether or not the sun recovers on time. The sun doesn't hold strictly to 11 years from cycle to cycle. And so we're now in the are we going to be allowed to have stereo and SDO and SOHO all being funded in this age where we've brought on ALMA and we're building the Large Synoptic Survey Telescope and we have James Webb and we still need to fund human beings. It's a scary time, and we're going to have to start turning things off, and choices are going to have to be made. So I don't know if we'll get to those 22 years. I'm hoping to see it through 2014 because I know people that work on the mission. Yeah, it's kind of ugly out there.
Well, there's not a lot in the L1 point. So is that a stable spot? Will it stay there forever?
To be clear, it's not precisely in the L1 position, because if it was, we'd have difficulties with radio communications with it. It's actually orbiting in a plane perpendicular to the orbit of the Earth around the Sun, going around and around that L1 point in this elliptical orbit around a geometric place in the solar system. It's a pseudo-stable position. Corrections do have to get made. So it'll stay there a while, but they do need to have fuel to keep it in a healthy orbit.
I see. So it's sort of like it's orbiting around this point so that we can still communicate with it and it can still watch the sun.
Yeah.
That's really cool.
So we're able to be in constant communications with it, and it still needs to use its thrusters to maintain its stability.
I'm going to see if I can try and get a spacecraft into that orbit in Kerbal Space Program.
That would be awesome.
Yeah, they've updated it, the game, so now you can. They've got a campaign mode now. So if you haven't already, Kerbal Space Program, definitely check it out. Cool. I have one last question for you, Pamela.
Okay.
Do you know where your passport is?
Yes, I know where my passport is. It's my airplane pillow that I have no clue where it is.
Oh, and you're going to need it.
Yeah, I'm about to shred my house very, very quickly.
All right, well, have a safe trip, and I'm sure I'll be watching what you do while you're in Indonesia, and we'll see you when you get back.
And all of our videos, the video of this live recording and all the videos from what we're doing at the Southeast Asian Young Astronomers Conference, they're all going to land on Astrosphere Vids, thanks to Richard Drum, who's really helping us out.
Thanks, Richard. All right, well, we'll see you whenever I see you next.
Okay, sounds good, Fraser.
All right, have a good trip.
Bye.
Okay.
Saving.
I am going to stop the... Oh, I should stop that. Okay, I'm going to stop the broadcast.
Okay.
So
bye-bye, everyone.
Thanks, everyone, for watching. Sorry it was so quick. What's coming up next? Weekly Space Hangout on Friday.
Learning Space. Today's...
Learning Space.
Wait, no, that was yesterday. Today's Thursday.
Yeah.
Yes. Weekly Space Hangout tomorrow.
Virtual Star Party on Sunday. No Astronomy Cast on Monday. Learning Space next Wednesday.
Yes.
All right. Cool. Well, thanks, everyone, for watching. Thanks, Pamela, for recording. Off to your plane.
Yes. Okay. Bye-bye, everyone.
What are you going to be doing?
I'm giving a talk on how you can maintain collaboration at a distance and be an effective scientist no matter where in the world you might be located. And I'm doing a workshop on all the technological tools that are available completely for free online for academics.
You may be an expert at this.
I just might. It's kind of surprising how rural America in some cases is just as underserviced as as the bigger cities in the developing world.
Yeah, but I mean, when you think about all the technology that we have at our disposal, all the stuff that we've brought to bear on this problem with the Hangouts and
and we've figured out how to do just about everything for free. And everything on my to-do list and not sleep or decide LAX was going to be pwned of internet.
They got pretty good internet there.
Yeah, they do.
Okay, so if you don't know what we're doing, we're going to do a live episode of Astronomy Cast, episode 322. Today's topic is SOHO. Normally we stick around for half an hour or so and answer your
Not
questions
today.
about space and astronomy. Not today. So Pamela's got to rush out the door the moment we finish.
Yeah.
And and so this will be Monday's episode. Now you're going to be back in time for the Monday after that.
Yeah, I will be extraordinarily jet lagged, like never before jet lagged, but yeah, I'll be back.
Interesting. All right. Well, we should pick a really philosophical topic then. Okay, cool. All right. Well, let's get rocking.
Okay.
I got a new monitor, so the positions are a little funny. Okay. I'm ready to press record whenever you are.
Okay. I am going to
Look at this
banish the
beard.
dog
Man,
that
I'm
just
like a
came
mountain
in.
man today, aren't I?
Hold on, I have a dog. You leave. Small, white, fuzzy, long-clawed dog on hardwood. Not good for recording. Okay, I've pressed record. Wow, that's big sound. Okay, I need to
Testing,
not project.
testing. I'm good.
Okay, I'm now good.
Okay, great. Here we go then. Hello, script. Okay. Astronomy Cast, episode 322, SOHO. There. I gotta turn that off. Okay, great. Can you hear me?
I can hear you.
All right, I can hear me. In like a couple of hours, you're gonna hop on a plane.
Yeah. So slight panic in the background here while I'm like doing the I left my airplane pillow where panic mode.
Take
But-
all those thoughts and just put them away.
Yeah.
All you need to think about is the sun.
No, all I have to think about is SOHO, which is not the same thing as the sun.
So where are you going?
Bandung, I think that's how you pronounce it, Indonesia. I'm going to the Southeast Asian Young Astronomers Conference.
That's really cool. So what do you?
We live off of the generosity of the people who donate to this program and to CosmoQuest, and with all the funding cuts going on, please donate to CosmoQuest. It's all I want for Christmas. It requires us to find new and creative ways to do amazing things as the money dries up.
Super interesting. So we're going to. No, it is interesting. I just know we got to move on.
Yeah.
That's really interesting, Pam. No. No, it's great. Are you going to be streaming any of this online or any of this?
Yeah, we're going to stream the entire conference. I will probably be starting to set up the Hangouts once I make it to LAX and finish a bunch of other things that are on my to-do list. I had a choice last night: complete everything